Hey everyone, welcome to AHN Education channel. I hope you have finished the chapters Animals and Plants. Now let us get into states of matter. First of all, what is matter? Matter is anything that takes up space and has some mass. What is it? Anything that takes up space and has mass. So any type of matter that you take, it means like any form of matter you take, it will surely have some mass, okay, and it will occupy some space, okay. It can be in different forms like solid, liquid or gas. So what is all this classification about? Okay, it will be mainly based on the particles, if the particles are closely packed to each other or not. Okay, the main criteria would be that based on which all other properties will come up. Okay, so it is very important first of all to understand how the particles are related to one another, how much amount of force is in between these molecules and how tightly or loosely they are packed, and with that comes the shape, size and volume of the matter. Okay, so now here we will get into the details of the solids, liquids and gases. Okay, firstly I want to say about the solids. Okay, these have definite shape, size and volume. So they have definite shape. Okay, when you take some cube, it will definitely have this shape, right? Okay, and when how about the size? Its size will be almost the same, and its volume, the volume it's occupying will also be the same. It is because the particles in a solid are very closely packed to each other. This is what I said, it is very important. First of all, what is meant by particles? Tell me that. Particles means the atoms and molecules. Okay, atoms and molecules. So when atoms or molecules are tightly packed, very closely packed in a way that there is hardly any space left for these particles to be compressed. Okay, so in that sort of things you can say that they are solids. Examples include anything solid. See, we use the word solid in so general form that when I say solid, any solid I am saying, right? So examples include a book, a toy and a rock. They don't change shape unless you cut, break or bend them. It means that they are so rigid. Okay, if I get into the details of the properties of solids, I can say that they have definite shape, okay, definite mass and definite volume. Okay, so all these are important properties of the solids. When I say uh, what are solids, you have to say that solids are a form of matter that has definite shape, mass and volume. Okay, and all these are additional things. I say that even those are important, but these are getting into more details, but the basic definition goes with the this first statement, definite shape, mass and volume. So how about the other properties? High density. What is meant by high density? High density means, as I said earlier, particles are packed so closely with one another. Okay, so when what is meant by density? First of all, if you take this amount of area, if there are too many things like this, okay, okay, if there are particles like this and the same amount of area I take here and the particles are scarcely spread like this, okay, so which is considered to be more dense? This is considered to be more dense. Okay, so density and closely packed to each other almost means the same. So high density, solids will have high density, and also because of this what happens, you know, for a given volume, okay, for a given volume you will find that the solids will be heavier as compared to the liquids and gases. Okay, maybe that this is a bit difficult for you to understand at this level. You can just say that solids have high density as compared to liquids and gases. Okay, and rigidity, and rigidity means, you know that, right? It's like firmness. Okay, they are as the particles in solids are tightly packed with one another, the solids can't flow. Okay, they will be very tightly closely packed with lot of attraction in between them, that they can't flow. Okay, the flowing property is not of solids. Okay, solids can't flow, you all know that, right? With the common sense we know that solids can't flow. So this one will be, the flowing property will be associated with rigidity. Rigidity, when there is rigidity there won't be any flowing. Okay, and as said, very closely packed with each other. Okay, so it means rigidity. And incompressibility, what is incompressibility? When you compress something, okay, it means if you apply some pressure on some solid surface, it won't tend to lose its shape, like it won't there won't be any change in the volume. Okay, volume means the space occupied, right? So there won't be any change in the volume, except there may be some change, a very minimal change, but you can't find any substantial change in the volume. Okay, incompressibility. And they have the position of the particles are fixed, and as said, there will be held by the strong forces. Okay, strong forces make them to stay close with one another. Okay, so as I have mentioned, everything goes with this single term, very closely packed to each other. Okay, and if I have to get into more details, then I can say that solids can also be of two different types. Okay, this may not be important. Okay, but I just want to let you know, crystalline and what is that, amorphous. Amorphous. Okay, I'll write it properly so that crystalline and amorphous. What is it? Amorphous. These are the two types of solids. It is basically based on the pattern of the arrangement of the particles. Okay, here you can find that the pattern is regular and repeated. Okay, so it is so organized, very nicely organized. And in the amorphous, they are randomly arranged. Okay, this is more than enough for 4th grade. Okay, I don't want to get into more details, and there is lot of information here, and but the most important thing will be this point. Okay, definite shape, mass and volume, and they will have high density, they are rigid. Okay, it's enough. What I'm saying is it is enough that you put in your mind that high density and rigidity are the properties of solids. You need not delve in detail about high density, rigidity and all that. Okay, so incompressibility means they can't be compressed. Okay, so let us get into the next form of matter, that is liquid. Okay, so liquids are, in liquids what happens, particles are not very closely packed. As I said, when solids are closely packed like this, okay, if you consider this to be a solid, they are very closely packed. Okay, and in liquids they are a bit fine. Okay, not so closely packed as solids, but it won't be as loosely packed as gases too. So if I consider the packing of the particles, okay, in solids it will be very tight. Okay, very tight. And uh, in liquids as compared to solids, they are a bit loose, and in gases the particles are very loose. Okay, so because of this, what happens, as the particles are not so very closely packed, they can move around. Okay, and they don't have fixed shape but have fixed volume and take the shape of the container. So if you take a glass of water, okay, and if you pour it in a round pot, okay, and if you take the same glass of water and if you pour it in a bottle, okay, here the shape of water will be of the container, like here it will be of circular shape almost, and here it will be of rectangular shape. So they don't have definite shape, they take the shape of the container. Okay, what are the examples? Water, milk and juice. Okay, and but they have what? They have fixed definite volume and mass. Okay, you can definitely say that this amount of volume of water, this is the mass of the water, but you can't say that this is the shape of the water, right? The shape will go with the container that is holding it. And fluidity, what is meant by fluidity? Fluidity means flow. You can is so as I have mentioned earlier, rigidity and fluidity are the opposites. Rigidity and fluidity are opposites. Okay, fluidity means to be able to flow. When the particles can flow, if they are a bit loosely packed, right? I don't say that they are very loosely packed like gases, but they are a bit loosely packed. That is, the attraction between the particles is a bit less. So if these two particles are like this, and if there is some amount of attraction, but if the particle says that I want to go this side, then this particle won't it doesn't stop this particle to move away from it. But whereas in solids, because of the strong attraction that will be there in between these two, this particle won't allow this particle to break this bond. Okay, this force. Okay, so I think you understood that, or I don't know if I have complicated it further. It's very easy or convenient for you to understand that liquids can flow. Okay, very easy thing. Instead of getting into all this like the attraction and all that. And how about the surface tension? Surface tension is a concept that you don't need at this level, but I'll just give you one basic thing. Okay, liquids have surface tension. That is what the point that will be important for your Olympiads. All these details I have added for Olympiads. In your academics, you won't have this. You can be very happy if you know this, and if you say that they can flow. Okay, and if you can say that in incompressibility, these are enough. These 3 points, with these 3 points you can do with the academics, and most probably even this is enough for Olympiads too. But I'm giving you a bit more details because I want you to give your best in your Olympiad and any competitive exams. And also, see, knowledge, it's good to be more acquainted with all the things and details, right? So there's no loss, just listen to it. Okay, if it stays in your brain, then it will be good enough. If it doesn't, that's fine. What are important? These three are important. Okay, surface tension. What is surface tension? So I'll just want to say one thing. There will be, if you pour some water in this, okay, this surface, there will be a surface right at the top. This surface of the liquid behaves like a stretched elastic sheet. What is it? Stretched elastic sheet. So if you take any balloon and if you stretch it, not a fully blown balloon, I'm saying that if you take a balloon and if you stretch it, okay, you can find that it has become flat, right? So anything can stay on that, like if you take small things, it can stay on that, right? So in the same manner, the top layer of the liquid will behave like a stretched elastic sheet, and some insects also can crawl on this. Okay, fine. This is about the surface tension. Liquids do have surface tension. If at all Olympiads or any competitive examinations wants to ask something about it, they will just ask you one statement: surface tension is can be associated with what form of matter? You have to say liquids. Okay. And then density. How about the density? As I have mentioned earlier, this is related to what? Packing of the particles, right? So in solids, they are very closely packed, so high density, and then comes liquids, okay, and then comes gases. So liquids are less denser than solids and more denser than gases. And incompressibility, you can't compress even the liquids. Like solids, even these are incompressible. Okay. And diffusion, what is meant by diffusion? So if you take what do you say, a glass of water, okay, and if you pour some ink in it, ink, either blue ink or black ink, anything, okay, after after a moment or so, the water in here also will turn light bluish or something like that, right? So why does this happen? It is because of this property called as diffusion. Here what happens, particles of different liquids can mix, okay, so this is one. And viscosity, okay, viscosity is related to resistance of liquids, okay. So it is enough that if you know that, I'll just tell you one example, okay. If you consider water and honey, okay, which can flow easily, you all know water can flow very easily, okay, rather than honey. So it means that waters are less viscous. What is that? Waters are less viscous or have less viscosity, and honey has more viscosity. So this is enough. Again, I am telling you that they may ask you this about the surface tension, diffusion, viscosity, as these are associated with which forms of matter, okay. Except for that, they won't get deeper into all these concepts, and as I have mentioned, it's better to know, okay. So go through it. If you have any doubts, let me know, but don't go into much details, okay. And about the gases, particles are very loosely packed. What is that? Very loosely packed. Here one particle, here one particle, here one, here one, here one, as compared to the solids and liquids. See, always when I say very loosely packed, there will be always some comparison, right, relative to something. That is most important. When you have to, when you want to understand some concepts, it is important that you know that the comparison will always be with something else, right, in the states of matter. If I say very loosely packed, as compared to solids and liquids, okay. So these have neither a definite shape nor volume, okay. So they won't have a definite shape, they won't have a definite volume, and these particles will move freely and fill any container. See, if you take this container and if you take big container, okay, you can make the gas, some amount of gas, okay, some mass of gas to be filled in, can be filled in this and also in this, okay. All the particles will freely move, okay, and it will be contained in that, what do you say, in that container, only because of the obstruction that is there, okay. It can be contained only by a container, okay. If you leave it, it will just move freely. So what is it? They can move freely and spread out to fill the container they are in. What are the examples? Examples include air, helium in balloons, oxygen, nitrogen and steam. And as I have mentioned, they can flow in all the directions. Now what are the properties? They don't have definite volume and shape. Fluidity. As said, fluidity means what? Flow. So as they are loosely packed, there's less attraction, and so they can flow more easily. Free flowing particles, implying that there are least forces of attractions. Can be compressed. See, there's a lot of space, right? So if you apply some pressure, they can be compressed. Compressed means they what do you call, the particles getting close to each other, okay, and they can exert pressure on the walls of the container, okay. This is the most important property of the gas. All the gases can exert pressure on the walls of the container, okay. This is important property. Now this is about the gases. We are done with the traditional things, traditional states of matter, that's solids, liquids and gases. Now let me introduce to the fourth state of matter. What is it? Plasma, okay. Beyond the traditional three states of matter, there is a fourth state known as plasma. Plasma is often referred to as the most common state of matter in the universe, as it makes up stars including the sun and other celestial bodies, okay. This is the fourth state of matter, and there have, it's like a topic that's above your this one. So not all the details are out on this plasma, but our scientists have some details on it, but at this stage we don't want to get into plasma. Okay, but if someone asks you, do you know the fourth state of matter, then you should say that yes, plasma. Or if someone says that, someone means in your competitive examinations also, if they ask you that there are only three states of matter, is it true or false, then you can like you can think in that angle that there is also a fourth state of matter, right? Only word makes some take some importance. Okay, if they say only solids, liquids and gases are the forms of matter, then you have to reconsider it as there is also fourth state of matter, right? Okay. Next, the other topic is conversion of matter from one state to another. Now see, we have this standard things like solids, liquids and gases. Okay, now the question that may come to your mind, that can a solid become liquid, or can a liquid become gas? Can a solid become gas? Can a gas become solid? Can a liquid become gas? Or liquids to solid? Yes, there is, it is possible that the matters can convert from one form to another. Okay, matters can change from one state to another. These changes are often due to what? Due to the addition or removal of energy, usually in the form of heat. So how is it possible? How will a solid change to liquid? Okay, or liquid change to solid? Okay, every time this sort the when every time when there are these conversions involved, then there will always be addition or removal of energy, and this energy will be in the form of heat. Okay, now let us see what are the processes called. What are the, here are the main processes. What is that? Melting, solid to liquid. So when one substance turns from solid to liquid, it is called as melting. Okay, you know, the popular thing is ice melting into water. We use this word so often, right? So melting means solid to liquid. When a solid is heated, its particles gain energy and start to move more freely, breaking the fixed structure. This process is called melting, right? What did I say? Solids, in solids the particles have a fixed structure and they are closely packed, right? When it is heated, what happens? Any particle, if it gets heated up, it will gain energy, and when you have more energy, you will jump, move freely, you will be always very active, right? So the particles, so even the particles, when they gain energy, they'll start moving freely, and so this fixed structure will be broken. So automatically when this fixed structure is broken, they these particles will move away from each other, and so they will acquire the property of flowing. Okay, so when this happens, it means that they became liquids. Okay, so melting means ice melting into water. And the next thing, freezing. What is meant by freezing? You always put your liquids, your water in the in your refrigerator, okay, in the freezer compartment of your refrigerator, and what do you get back? You will get solid ice, right? So water changing into solid is called as freezing. When a liquid is cooled, its particles lose energy and move less, arranging themselves into a fixed structure. This process is called freezing or solidification. So what happens when a liquid is cooled? Its particles lose energy and move less. See, only one thing you have to remember, the standard thing. When there is more heat, when the heat is given, the particles will become more active. Okay, when the heat is taken off, it means that if you put the liquid into the refrigerator, it gets cooled, so the particles lose energy and they move less, and so they arrange themselves into a fixed structure. This process is called freezing or solidification, and the example will be water freezing into ice. And next, evaporation. Okay, what is evaporation? Evaporation means liquids turning into gas. When a liquid is heated, what happens? What is happening here? When a liquid is heated, its particles gain enough energy. Okay, so heat is given, and so its particles gain enough energy to break free from the surface and become a gas. This process is called as evaporation. Okay, water evaporating into the water vapor. Because of this, we we get rains, right? So precipitation is possible only because of evaporation. Precipitation means rain. Okay. Next is condensation. What is condensation? Gas to liquid. When a gas is cooled, its particles lose energy. Again I said cool, lose energy, and come closer together to form a liquid. This process is called condensation. Water vapor condensing into droplets on a cold surface. The popular example that I can say to you is, if you put some water, okay, water on the stove, and when there is steam coming from there, if you put any plate, okay, you can find that this water vapor will turn to droplets on this surface. Okay, this is called as condensation. And next thing is sublimation. What is sublimation? Solid to gas. When a solid gains enough energy, it can change directly into gas without becoming a liquid first. This process is called sublimation. See, till now what we had been seeing is solids, liquids, gases, solid to liquid and liquid to solid, liquid to gas and gas to liquid. Okay, but now this process is called sublimation, wherein when these particles have gained enough energy, it means that they got so much of heat that they have directly converted to gas instead of getting into liquids. Okay, so this process is called as what? Sublimation. What is it? Sublimation. And the example to this is dry ice sublimating into carbon dioxide gas. Okay. Now next is deposition. Here gas getting converted directly into solid, skipping the liquid state of matter. It's called as deposition. When a gas loses enough energy, it can change directly into a solid without becoming a liquid first. This process is called as deposition. Okay, what is the example? Frost coming on a cold surface from water vapor in the air. Okay, and the next process is ionization. What is ionization? A gas turning into plasma is called as ionization, and plasma turning into gas is called as deionization. This is enough for you at this stage. Okay, now again, in order to give an overview, I can tell you that there will be solids, liquids and gases, right? So when solids get converted to liquids, that process is called as melting, and when liquids get converted to gases, it is called as evaporation. Okay, now when liquids get converted to solids, this process is called as freezing. When gases get converted to liquids, this process is called as condensation. Okay, so these are straight things: solids, liquids, gases. They are following the rule. Okay, but when when a solid skips off liquid and directly gets into gas stage, gas form, then it is called as sublimation. What is it? If it goes like this process is called as sublimation. And the same manner, when gas without getting into the form of liquid becomes a solid directly, then this process is called as deposition. Okay, so this is about the conversion of the forms of matter. Okay, and other thing I just want to let you know is why it is important to learn about the solids, liquids and gases. We have spent almost like half an hour on this, so it's very important to understand why are all these important, so that it can be you can understand how all this will be put practically in your real life. Okay, so about the solids. Okay, solids, where all these can be considered in your daily life in uh, engineering areas and construction and material sciences. it is very important you understand the varied nuances of this form of the properties of the solids. Okay, so why is it important? See, if you have to build some sturdy bridges, or you want to build some flexible electrical things, okay, for anything you should know the properties of that particular matter. Okay, like as I said, not all solids will behave in the same manner. Okay, they will be different. So in order to understand the what do you call, the characteristics of any solid, it is important that we specify the properties and we understand it in terms of the properties. Okay, so you with regard to the solids, I can say that this will be the area like practical application. Okay, this is only for your knowledge. I don't think this will be of any use for your exams, Olympiads, or that other things. Next, liquids. Okay, where can you find the practical applicability of liquids? Just think. Same, we will go with this engineering and construction itself. Okay, in engineering and construction, designing of pipes and containers, and all these will take the properties of fluidity of the liquids, means that how they flow, right, their viscosity, all these matters, right. So it is about in the engineering and construction. And if you take in the medical field, in medical field there will be so many solutions prepared, right. So for all these two, you will have to consider take into account the properties of the liquids and do the things. Okay, now this is enough as far as the states of matter topic is concerned. And one thing I want to say, there is one exception, like I told that in solids they are very tightly packed, right, as compared to the liquids. There is one exception to this. You always know that ice and liquid are like converting states, right. Ice, when ice which is in solid form, when it turns into liquid form, it will become water, right. So in ice, actually in ice they should be more tightly packed as compared to liquid, but it's opposite here. This is the exception that you have to remember. In ice you can find that the particles are more less tightly packed than liquid. Okay, so liquid, not liquid, water. Okay, done with the chapter. Okay, I'll see next chapter what should I go with. Okay, see you soon, bye.